So what makes this program so great is the amount of transformation that you see within yourself. When we first got here, it was like an unveiling into a whole new world at business and at life around us by using digital transformation.
Data analytics, business analytics, text mining, regression, all of these can actually be implemented and used in public health, in any other place that you want to use. So why not just go save the world with it?
The applied project is also a bonus because this university and this degree actually offers you the chance of working with a renowned company, a company that has a real life project.
I had several options in almost every state, but UW had a different program which gave me an opportunity to work for a company which is an applied project. That particular course structure gave us an opportunity to work with different companies and actually really implement your skills and come up with some proven results. That's one of the biggest reasons why I chose UW MSBA.
What makes UW-T special for me is the fact that it's in Tacoma, it's not in Seattle. I think there's a lot of focus on Seattle and the bigger cities. It's a much more intimate feel with smaller class sizes. You don't have to go up to Seattle to fight the traffic and congestion to be able to have access to a world-class program.
Well, hello, UW-Tacoma Milgard students, both all of you new ones and you that are completing your work here at UW-Tacoma this quarter. This is a wonderful activity and a fantastic example of our urban serving mission. Now, I understand that this is the third annual one of these MS Business Analytics Applied Project Showcase competitions, and that there's 76 of you graduating with your MSBA in a week or so, and you're presenting these to over 19 companies today. Wow, that is very impressive. I also understand that there are representatives from these 19 companies with you here today online. So welcome to all of you, students and companies alike. We're very happy to have you here. So why is this work so important? Why is this project so important? Well, first of all, I believe it provides you with real issues in the workplace to add to your educational attainment here at UW-Tacoma. Also, secondly, you as students with creative and expertise, energy, are able to help these companies with real projects that they have currently in the workplace. To me, it seems like a win-win situation for everybody. You know, this really gets to the heart of our mission at UW-Tacoma. We believe this institution is here, especially for the people of the South Puget Sound and the businesses of the South Puget Sound. What I like to say is that UW-T is of the people, by the people, and for the people of Tacoma and the South Puget Sound. You know, along these same lines, UW-Tacoma is distinguishing itself nationally in this work. Over the past few years, we've established an Office of Community Partnerships to help support this work. And you know, this past January, we were formally recognized as a Carnegie Community Engaged Campus. This prestigious designation represents less than 10% of the public institutions across the U.S. So let me congratulate you again on your achievement in this awesome course project in one of the premier business schools in the country, located on this exceptional campus in my favorite city in the world, Tacoma, Washington. So congratulations and thank you very much.
Hello, I'm Jill Purdy, and I'm the Executive Vice Chancellor for Academic Affairs at UW-Tacoma. I'm also a professor of management in the Milgard School of Business. I'm delighted to welcome you today to our third annual MSBA Applied Project Showcase, where we get to show off the hard work of our students along with the faculty and staff who support them. 76 students who have worked with 19 partner organizations to develop analytics solutions to challenges and opportunities faced by these organizations. Our partners are drawn from the business, government, and nonprofit sectors, and our students have become very engaged in finding terrific out-of-the-box solutions for the challenges these organizations have identified and partnered with us on. I know you'll enjoy hearing all about the students' hard work and their innovative ideas. Thank you for participating with us today.
Thank you for joining us. We are the Tacoma Power Outage Management Analytics Project Team. I'm John Cannon, the project manager. We also have on the team Sandeep Vadluri, our business strategist, Terry Benitez, our software developer, and Chad Sizemore, our business analyst. A little bit of background about Tacoma Power. They are a major publicly owned electric utility that owns and operates 7 hydroelectric dams and generates about half of their own power, with 180,000 customers in and around Tacoma. Their mission is to provide safe, reliable, and environmentally responsible electric and telecommunications services now and into the future. The business problem we face is regarding system reliability. So that is addressing power outages, which are planned for scheduled maintenance and other reasons, and unplanned due to equipment failure, storms, and a variety of other factors. For this project, we work with the Tacoma Power Dispatch team with data from their outage management system, which is their enterprise system for managing outages. The key performance indicators that Tacoma Power uses that we'll be addressing in this presentation are System Average Interruption Frequency Index, which is the total number of interruptions divided by the number of customers served, and the System Average Interruption Duration Index, which is a sum of all customer interruption durations divided by the total number of customers served. The primary objective of our project is to facilitate a positive effect on the company's system reliability with usage of Tableau reports and visualizations used by dispatchers and management. Secondary objective was to explore the relationship between weather variables and to see if those are predictive of system reliability. And lastly, we also took a look at managing customer expectations of outage resolution using cognitive analytics. Our project phases were broken down into 4 phases, which we will discuss in a little more detail. In phase 1, which was our discover and plan portion, we did a thorough industry analysis which was unique and peculiar for a heavily regulated industry such as power distribution. We used Porter's 5 Forces framework, and we also did a pestle analysis, which looks at political, economic, social, technological, legal, and environmental factors. We also did a thorough company analysis on Tacoma Power using Porter's SWOT framework, looking at their internal strengths and weaknesses, external opportunities and threats. And we also developed a business model canvas for Tacoma Power. Also in phase 1, we developed our project scope and began working with the data. So our data was primarily contained in the outage management system, also files from the Tacoma Power network. We had a data pipeline with AWS architecture. The tools we used were Azure Machine Learning Studio, Power BI, Azure Cognitive Services, and for dashboards and visualizations, we used Tableau and Power BI. In phase 2, we began developing descriptive analytics, moving on to diagnostic analytics. For the descriptive portion, we looked at the quarterly SAIDI values for system reliability and looked to see how they coincided with major weather events. As you can see from the chart on the left, many of the big snowstorms that we've had in the winter correspond to a negative impact in quarterly SAIDI. With that in mind, we also took several variables from NOAA weather stations in the area, looking at the low temperature, amount of precipitation, average winds, maximum 5-second sustained winds, and maximum 2-minute sustained wind velocity. On the chart on the right, you can see that each quarter was negatively impacted by a high 2-minute sustained wind velocity average for each of those days. Taking a little bit further at the weather variables as they relate to system reliability, we found that minimum temperature, when you do a regression, only had a 9.7% coefficient of correlation, and precipitation was also similarly low. The wind variables had a much higher coefficient of correlation, with average wind having a 32% R-squared, 5-second maximum sustained winds with a 58% R-squared, and 2-minute maximum sustained winds with a 62% R-squared. And now Sandeep's going to explain a little bit about what we've done in phase 3 of our project.
Thank you, John. As you notice, in phase 1 and phase 2, we spent time on understanding the business, collecting and storing the data from their OMS system, and trying to understand the data using descriptive analytics. In phase 3, the develop phase, we looked at data preparation and modeling. More specifically, we developed a predictive and prescriptive analytics model. A predictive analytics model aims to determine what's likely to happen in the future. For this, we chose the task of predicting the number of outages so that Tacoma Power can plan their restoration efforts ahead of time. Since major outages are caused by weather-related events, we attempted to predict the number of outages using weather variables such as maximum and minimum temperature, precipitation, and wind speed. We used outage data from Tacoma Power's OMS system and trained a decision forest classifier, which was able to predict the outage severity with a 26% overall accuracy and 75% average accuracy. Our next task was prescriptive analytics. Prescriptive analytics is using insights from descriptive and predictive analytics to determine the best course of business action Tacoma Power can take. For this, we wanted to answer the question about the number of crew Tacoma Power needs to maintain in order to safely and reliably restore power while maintaining its SAIDI target metric. We modeled the optimal number of crew using historical outage numbers and SAIDI using a multivariate linear regression model. The outcome was a model that could be used to calculate optimal number of crew with an RMSE of 2.3. In the last quarter, we moved on to phase 4 of the project, which was the deploy phase. We looked at where we could use cognitive analytics in our digital solutions. Cognitive analytics is building intelligent and supported into apps, websites, and bots to see, hear, speak, and interpret user needs for Tacoma Power. One low-hanging fruit that we found was the opportunity to use natural language processing to build a customer engagement tool for Tacoma Power's website. We chose to build a question-answer chatbot using some of Tacoma Power's website information as the knowledge base. We chose Microsoft's Cognitive Analytics Toolkit to build this, and in a short while, you will see a demo of how that works. The other task that we performed in phase 4 was to come up with a digital transformation plan for Tacoma Power to adopt our digital solutions. We analyzed major enterprise level transformation. We looked at transformation of major parts of value chain, such as customer relations and operations, and transformation of business processes related to outage management. By adopting our solutions, Tacoma Power can not only gain competitive edge, but also achieve better reliability metrics. We suggested a technology plan in terms of architecture necessary, did a cost-benefit analysis, and suggested a plan for rollout and monitoring of our solutions. Lastly, before we move on to the demo, here are the digital solutions that we proposed and their important aspects. Our predictive and prescriptive model helps Tacoma Power to anticipate outages and prepare in advance and improve their time to restoration. Our OMS dashboard will help Tacoma Power monitor outages and improve management situational awareness, and also give them the opportunity to drill down and analyze their historical performance. The chatbot that we developed will serve as a prototype solution for Tacoma Power to manage customer expectations with the goal of improving their overall customer satisfaction. With that summary, I'll request my colleague Terry to give you a demo of our solutions.
Thank you, Sandeep. So what I'm going to be doing is pretty much sharing the demo that we ended up making through Microsoft Azure. We ended up using the Microsoft Azure chatbot framework mainly because we could potentially set it up to use different tools. The main tools the group and I used in order for the chatbot to work were the FAQs, the frequently asked questions already given onto one of the Tacoma Power websites. And we're gonna go ahead and test it out right now. So we're just gonna go ahead and greet the chatbot and say, hey, and it's asking us how the chatbot can help us. Let's just say that we might have a power outage. I think I have a power outage. Okay, so please check the following map. And it redirects us to this map right here that's already built in the Tacoma Power website. And it's telling us to whether or not we see the power outage there, and to say if it is accounted for or if it's not accounted for. If it is, we go ahead and click yes, and the answer is going to let us know is, thank you for letting us know. Please wait for power restoration. Is there anything else that we can help you with? Let's say that there is. Let's say that we're trying to become customers. I want to be a customer. So it's going to say to call one of the representatives in order for us to sign up. And it also tells us that we can also go visit Tacoma Power Utilities main website and have the customer go through all the products that they can choose from while they're waiting for their phone call to get picked up. Let's just go back to the section and say that the power outage that we were trying to report is now being shown within the map already given to us by Tacoma Power. Let's see what the chatbot says. It says, please call our outage number at this number for further processing. Meaning that even if we're trying to report a certain power outage and it's not already shown in this map, then it's telling the customer to call the number in order for them to tell Tacoma Power to make sure that they are tracking about this location. that is having difficulties. And the OMS is also dependent by people calling in and reporting all these different power outages. With that being said, I'm going to leave the floor to Chad.
Thanks, Terry. Now I'll discuss our OMS dashboard for Tacoma Power. What our OMS dashboard shows is gives Tacoma Power a picture of the customer outages over any given period of time. They can look back as far as 30 days or as few as 1. For example, we'll look back 4 days. Over that 4-day period of time, ending on August 1st, 2013, we can see the number of customers that were out by circuit. Over that 4-day period of time, 12 customers were out in Elk Plain 3. We can see the same thing by district. Over that period of time, Loveland had 56 customers out. We can also see the restoration time accuracy of those outages. That is, we can see the amount of time that it took to actually restore power over the estimated amount of time it was going to take to actually to bring power back on. Furthermore, each of these incidents can be singled out as a specific incident with the duration of the outage, along with the number of customers that were affected during that outage. You can also see the number of customers out as a running total over any given period of time. Lastly, we can also drill down at any point in time to get additional details. For example, we can click on West Side, see that 2 customers were out. And when we click on it, you can see that the duration of that outage was 42.85 minutes. The incident ID associated ended in 382. You can also see that it started at 11:05. Note that it says the number of customers out are 14, but that is in total during that time frame. Once we wait until power is restored at approximately 11:47, it goes back down 2 customers, back down to 12. If we zoom out, we can see at this small point in time at 11:04, the customers moved up to the number of customers out to 14, and then power was restored once again. That sums up our OMS dashboard. John?
All right, thank you, Chad. For any questions about our Tacoma Power Outage Management Analytics project, we will be conducting a poster session, a live poster session at 1 p.m. today. On behalf of the MSBA students from the Applied Project team, we'd like to thank the Tacoma Power team for the opportunity to learn the industry and to develop a solution. Special thanks to Travis Metcalf and Andrew Brager for all they have done to help us along the way. So with that, we would like to see you at 1 o'clock. Thank you.
Hi, everybody. This is Jashandeep, and we are Team B7 for Metropolitan Appliance. And we have been working with Metropolitan Appliance from last 1 year, and we want to share this whole work that we have accomplished so far with you. And thank you for your time again. Here's a quick background for the company. We are Metropolitan Appliance is an independent, locally owned business located in Seattle, a SoDo neighborhood of Seattle, and near T-Mobile Park, which was known as Safeco Field back in the day. And they have about 25 employees, which is why they are called small business. And we are glad that we got the opportunity to work with them. And here's our backbone of our team, which is Dr. Haluk and Dr. Michael. We really appreciate their work and supporting us all through this, and being with us all the hard times that we have been working on this project. And here is our quick introduction for our team. Myself, Jashandeep, as I said, project manager, and then we have our Jyot Kaur. She worked as a data analyst. And then we have Sharmishta, she worked as a BI engineer in our team. And then we have Bernie, who worked as a data scientist. So here's a quick problem overview that we are trying to solve for Metropolitan Appliance. Problem is that Metropolitan Appliance has very less digital presence, and our solution to them is to expand that digital footprint for them. And the challenge is there are already big stores which are already existing in the market, like Best Buy and Home Depot, but there is always an opportunity to increase their footprints in the regional level. For example, relative to their competitor, which is Albert Lee, they do not have digital presence, but that there's an opportunity for Metropolitan Appliance to increase in that market. So I would like to thank here Metropolitan Appliance leadership, which is Aaron, for giving us the opportunity and trusting us and sharing this data with us as far as POS data is concerned and internet sales. Also income expenditure data, including Google Analytics, which is the website data that he shared. This gave us the opportunity to work on the data and analytics side and give him a wonderful recommendation / solutions for the problem that we are trying to solve. So now I would ask Sharmishta to go over the Google Analytics, which was the first thing we did as far as the whole project is concerned.
Thank you, Jashandeep. And as the website was the main business pain point, their limited presence. So we did a Google Analytics analysis, and we selected a couple of KPIs to work on. And the KPIs are basically the new and returning customers, bounce rate, search exit, source acquisition, channel, and conversion. So we did the analysis on Tableau, and this is what our Tableau dashboard looks like. And we have some key observations from the analysis that we did on Tableau on Google Analytics. So we found that organic search was working better than a paid search and a direct search for Metropolitan Appliance. And the bounce rate was pretty high irrespective of the channels. And the search exit was maximum in 2019 Q3, and it was from the deals page. So their deals and marketing strategy was not doing well for them. We also found that Google has the maximum source acquisition and social media doesn't have much impact. So that was a problem as well, because the current generation mainly spends the time in social media rather than on Google. We also found that purchase conversion was also meager for them in the website. So to analyze further, we had some analysis done on their internet sales, and this was also done on Tableau. And we found out that dryer, top freezer, refrigerator, electric range, and OTI microwave were not performing as per expectation, and they were not giving us much profit. We can also see that the brands like Maytag, Electrolux, and Whirlpool are not giving us the profit that we need. So, and we also found out the profit margins of different various brands, and we found that Maytag, Fisher-Paykel, Frigidaire, and Whirlpool had poor profit margins. So these analyses were done to find the problem in the website, and to resolve these problems, we moved on with market basket analysis so that we could suggest them some recommendations on bundles. So I'll hand it over to Amarjot for the market basket analysis explanation.
Thank you, Sharmishta. So before I show you the numbers and visualizations for market basket analysis, I'll just give you a quick overview what market basket analysis is. So basically, market basket analysis is a modeling technique which is based upon a theory which says if a customer buys a certain group of items, that customer is more likely to buy another group of items. So in short, I would say this is just finding out the relationship between the products and then making a set and bundles of those products. So moving on the visualization. Now, if you see this visualization, all the numbers which you see in the green, red, and orange, these are the number of occurrences, like how many times these two products were ordered together. So if you see bottom freezer, refrigerator, and dishwasher, it is ordered 563 times together. So which clearly represents that these two products can go in a good bundle and can be effective for increasing our revenues. So with the same approach, we figured out few bundles, and those bundles will be recommended as putting on their website to increase their revenues and profit. As you see, for example, microwave non-OTR can go with bottom freezer refrigerator, built-in refrigerator, dishwasher, dryer, and gas range. So these are few kind of bundles which will be recommended for website presentation, and they will have more effective impact in terms of increasing revenue. So now we will move on to association rule mining, and Bunny will give you a quick overview how these bundles can be more accurate while we are making strategies. So over to you, Bunny. Thank you.
Thank you, Amarjot. So as you can see in Tableau, it was more of how a product A was associated with product B. But with association rule mining, what we get is how a pair of product is associated. So the input to this rule is basically the list of purchases done by the customer. It is the past transaction data that we provide as an input, and the output that we get from these rules are the rules that we get. These are more like if a person buys A and B, then we can be sure that he can end up buying C as well. So these are the rules that we get out of the analysis. So the base of the analysis is to understand how the data is distributed. So as you can see, the data distribution here on a month wise, around November and December, we see very limited transaction trend. Ideally, these are the time when people go in for deals and buy in bulk. So this was one analysis. Another analysis that goes in is to understand how frequent an item is bought. As you can see here, the dishwasher is being bought more, followed by washer, dryer, and the least one is at the end, the coffee center. So these two form the base of the algorithm, and the output that we get are the rules. So these are the set of 8 rules that we got from the algorithm. And the first one goes like, if a person buys bottom freezer, refrigerator, and washer, then we can be sure that he's going to end up buying dryer as well. So how do you know if this rule is legit? Is based of 3 metrics. One is support, confidence, and lift. So the support says how frequent has this item occurred in the transaction, in the past transaction. And the confidence says if a person has already added something to their bag, like they've added bottom freezer and the washer, and then how confident can we be if a person is going to end up buying dryer as well. And the lift says that this rule is not happened by chance, but it has actually happened based on the past transaction trend. So you can see the first rule says confidence is 96% and the second is 95. So this says how sure can we with the rules here. And so as you can see here, this is a diagrammatic representation of the rule. If a circle which is more wider and more brighter says they are closely related. So the washer and dishwasher are very closely related. While you can see the bottom freezer, refrigerator, and OTR microwave, they are very lightly related. Like their relations trend is very limited. So this was the association rule that we did. And then another analysis that went in was to understand the sentiments based of the review. So we integrated Microsoft Cognitive Service to understand how the customer's sentiment was towards the products bought. So we were able to extract close to 80 plus reviews from online, and we performed sentiment analysis. So as you can see, more than 80% of people had a positive notion towards the brand, while 16% was having a negative, and a very meager one around neutral. So just to understand what each of these polarity mean, we have sorted it down into 3 separate sections: positive, neutral, and negative. So if you can see in positive, people were very happy about the shopping experience and mostly about the delivery and installation service. They highly recommended it based off these 2 factors. Well, the neutral one was mostly around the notion that they were unaware of the brand until they noticed the store at random while driving. Right? They were totally not sure. The first option they go in was for the big boxes, while these they notice only when they drive by. So that was the general notion around the neutral sentiment. And the negative one was very limited. And to be specific, it was for a particular dishwasher, which was Esco dishwasher. And then there was a problem with CPS warranty. So these were like one or two reviews that had very bad sentiment, but most of it were around the positive and neutral. So this was for the complete brand as well. And if they can add in for each individual product, then we can understand how the sentiment for each product could be. So this was the analysis that went in. So based off all the analytics that we performed, we integrated all of it together in Power Apps, which Sharmishta will run through. Thank you.
Thank you, Vani. And now I'll show the Power App that we prepared for the Metropolitan Appliance Stock Management. That this Power App, they can use it on their mobile or tablet, and they can just see if their brands and their categories are working fine. So this is a Power App that we created, and Aaron is the president of Metropolitan Appliance, so I'll use his name here. So if I go in, so this is a Power BI Power App integration. So all the charts that you can see here has a master database in Power BI, and that can be updated on the background, and the top management can see what brands are performing at what level in their app. So moving forward, we can see that it can also show the market basket analysis that we did in Tableau, and this is done in Power BI. And this is the product recommendation, like what goes in with what. So if I type in here top freezer refrigerator, so we can see that the top freezer refrigerator has been ordered with Wildhood 54 times. So the people who are seeing this app don't need to go deep into the data to find what is going with what. He can just type in and see what combinations can be promoted on their website to increase their sales or average profit. So that is what we did in analysis part. And now over to Jashandeep for his recommendations. I'll go back and start the slide again. So moving over to...
Thank you, Sharmishta, and thank you whole team for explaining all the analysis. And I really appreciate the work that you have done so far. So quickly, I'll go on recommendations that we have concluded from all the analysis that we have done so far. So the first is to acquire new customers. So as we know that our organic search is working better than the direct or the paid search, so we would ask, or we would recommend Metropolitan Appliance to move their budget from Google to social media so that they can acquire new customers which are on social media but not on Google. And also the direct search, which is typing direct URL in the Metropolitan Appliance. People will get to know more about Metropolitan Appliance on social media so that they will do the direct search. So this will help acquiring new customers. And we also know that there is a high bounce rate and exit rate. To acquire and retain new customers, we should pay to Google to optimize our tags, to optimize our ads, having tags onto it. For example, if as a customer I search for an appliance, there should be a tag of appliance to it, which should directly take me to the Metropolitan Appliance. This will save customers time for what they're looking for and help them in checking out quickly. The other thing is having high exit rate, which is people are spending more time on exit rate, and they are having trouble finding actual deals and bundles what they're looking for. So we recommend Metropolitan Appliance to add more appealing deals so that they can easily understood by the customer, and this will help having them the purchase. And another thing, the third one is in the left bottom corner, which is the customers are spending more time on the website with less page view, which means like they're stuck on one page, but they're not going anywhere. They're just stuck on one page, and it's taking more time to go through that page and get understood what actually is on that page. So we recommend them to have deals as a basic improvement and add bundles so that people get to know what they should buy as soon as they get onto the website, which is on the top of the page. And then the second thing is add their bundles, which we recommended to the advertisement campaign, so that people can know and have on the first eye when they get onto the website. They get to see all that, which is again helping them to buy and fit the basic improvement of the website. And the fourth one, as Bernie did on the text analytics, so we know that people are already talking positive about Metropolitan Appliance. They should spend more energy and time on negative reviews rather than positive, because we already know they should continue doing that positivity. So the thing is that for negative, we have seen in those reviews that people are having trouble in post installation, which is after the installation, people are complaining about it, and Metropolitan Appliance as a company should invest their time and energy looking into those reviews and helping customers solving that. So this was our general recommendations. So moving on to our transformation plan. This is the 3-phase transformation plan, which is basic, intermediate, and advanced. Here we are recommending Metropolitan Appliance in the post-COVID-19 era. Basic is just with the very least or no investment, and intermediate is with little bit investment, and advanced is with actual bulk investment. So basic is like just do like general metrics improvement, adding purchase conversion and overall revenue. This will help Metropolitan Appliance to know what's going on the website, where the purchase conversion is high and where not, so that they can invest more onto that specific area. The other thing is in budget allocation, like I said, they should move from social media to Google Ads. Intermediate has several recommendations, which is with little money and with more money, of course, than basic, but less money, less investment than advanced. So it has basic improvements on the cart, adding reviews and Q&A for specific products, and bundles in the cart right before the checkout, and placement of deals right before, right when the customer lands on the home page, which is the landing page. They should have deals on the top so that customer can get an eye catch and get to those deals and go through the checkout. The advanced is specifically spending money, or I would say investing money on cognitive services given by Microsoft or any other company, and have a personalized platform for a specific customer, which is something like whenever a customer lands to your website, this whole website should have cookies and cache for that specific customer's already inbuilt it, and should use those cookies and cache to know what customer is looking for. Any customer who gets to your website should have be easily and smooth journey through the checkout. Actually, the problem that we have been seeing is that people are spending more time and not finding what they're looking for. That is where exactly this personalizer or helping improving search engine for the customer will help Metropolitan Appliance and, of course, customers in their smooth journey. So this was all about recommendations and transformation plan. So here is our team who has put it all together for Metropolitan Appliance and for, of course, for UW CBA, so that we can share the knowledge that we have learned so far in last 1 year. And I would like to thank again the whole CBA team, Aaron, and of course, specifically Dr. Haluk for helping us and sharing his knowledge to putting it all together. Thank you. Thank you, team, and thank you everybody who's watching us today. And we appreciate your time. Bye.
Bye.
Hello there, everyone. Thanks for attending our project showcase today. My name is Matt Janzo. I'm the project manager for Team B8. I'm excited to share with you the geospatial and visual analytics solution that our team has developed on behalf of our client, the Washington State Department of Natural Resources. This type of analysis is something that you won't find on any of the other team's projects this year, and we're proud to have been able to offer this solution to our client. Here to provide us with a little background on DNR and this project is my teammate and assistant project manager, Meredith Williamson.
Thank you, Matt. The Department of Natural Resources was established in 1957 to manage state trust lands, including forest, range, commercial, agricultural, and aquatic lands. DNR now encompasses over 5.6 million acres. These lands generate over $300 million annually for public schools, state institutions, and county services, and since 1970 have provided over $9 billion for communities and schools across Washington. Salmon have long been a significant contributor to Washington State's economy and a cherished part of the local culture. In 2011, Washington State Department of Fish and Wildlife reported $1.6 billion were generated from commercial fisheries. Salmon alone are estimated to generate over 100 million per year, and their decline in number have made them a subject of focus and concern for DNR. The Department of Natural Resources sought out the University of Washington MSBA program to assist with gathering and identifying data that supports salmon recovery efforts, identify ways to determine the likelihood of a parcel of land being converted, and provide a data-driven model to help predict land conversion. Our scope of our project was to determine the likelihood that an undeveloped parcel of land in Snohomish County will be developed. The FREP and FFF2P are two programs with DNR that will benefit from this land conversion prediction. We intend to use a growth model to provide an analytic solution for DNR. This model will help show how land use is changing over time and allow DNR to reach out to small parcel landowners that may be at risk for converting. We selected a strategic approach to allow DNR to continue this project in the future. For this to be accomplished, we selected an open source data, ensured the model would integrate with DNR's current systems, made sure it could be used quickly, and at no to low cost. The data sources we used were the DNR program data, again, the FREP program and the FFF2P, Snohomish County assessor data, GIS parcel data, and Sentinel-2 satellite imagery. Now to Nitika Raj, who acted as our data analyst for the project, for our descriptive and diagnostic analysis.
Thank you, Bedrit. So collected data set, we have collected assessor data set for the Snohomish County, and from those data set, we are trying to understand or find any trend or pattern among the features to get initial insights from the data set. So on the left-hand side of the map, we can see it represents the total number of parcels across each city for each property classes. On the right-hand side, we have filtered out the last 4 years parcels which has been sold and trying to identify which property class is the most dominating class among those parcels. So it was found that single family residence is the most dominating class among the parcels which has been sold in the last 4 years. And the overall trend for all the parcels which has been sold in the last 4 years, we can see there is an increasing trend for all the property classes. Next, moving next, we are trying to identify what is the change in the average sales value for all the parcels in the last 4 years. So it was found like into year 2019, we have seen there is a highest change in the average sales price for all the parcels. Even for some cases, it has increased from the current market value of the parcels. So we think that average sales value or market value could be a good predictor in predicting a parcels will be likely to sold in near future or not. Similarly, we have identified and we have initial understanding on few predictors and identified few predictors which could be a contributing factor in predicting parcels to be get sold in near future or not. So with all our analysis on the data set and all our understanding, we have created a model in using Azure ML Studio. So here is a quick overlook of that model. So we have created this model in Azure ML Studio using 2-class decision forest algorithm. And we got the accuracy of 93.2% and FN score as a 94.9%. And with a good precision and recall, we can see it's a more than 90%. So okay, so after creating this model, we have deployed this model as an Excel prediction calculator. And we have identified that there are top 8 predictors which are contributing to predict a parcel will be likely to sold or not. So here the scored label 0 and 1 showing 0 means a parcel will not get sold, and 1 saying that the parcel will be get sold with their respective scored probabilities. So moving on next, I'll hand over to Matt. He'll explain a little bit on our image classification model.
Thank you, Natika. To complement our growth model, we wanted to enable DNR to remotely monitor and observe land use changes easily and with minimal resource commitment. This required us to develop a land use classification model. To do this, we relied on the latest version of the National Land Cover Database, which is from 2016, and this served as our ground truth label data. And we obtained Earth observation data from Sentinel-2. We then developed a workflow in Python, which functions at a high level like this. First, we select a geographic area of interest and obtain imagery and land use data for it. We then prepare the data for modeling by performing any necessary geo-projection and scaling adjustments, as well as cloud removal and other minor corrections. Following these steps, we train our model. We use the 2016 NLCD land use data as our label and 2016 Sentinel imagery in an 80-20 training and test split to do this. This allowed us to conduct our next step, which is training model validation. The validation of the model lets us determine its predicted accuracy and ensures that the prior steps in the workflow were done correctly. And then last, we can visualize the output with the predicted land use classes displayed as an image. So a key benefit of our land use classification model is that it enables DNR to use present day imagery without having present day NLCD ground truth label to go with it. This allows DNR to observe changes in land use without having to wait for the next version of the NLCD data to be published. In this example, shown on screen, we're sending a satellite image from 2019 through the classification model that was trained using images and NLCD ground label truth data from 2016. The model can then interpret the pixels in the image from 2019 without any ground use labels and predict the land use classifications as shown. We evaluated 3 different models as part of our project and determined that the light GBM model was the most accurate with an overall classification accuracy of about 78%. It's a form of a boosted decision tree and has a very fast training time and overall had the best classification of the land use types in our sample data. Here's the receiver operating curve for our light GBM model. What we're seeing here basically is telling us how the model is, how much of the model is capable of distinguishing between the classes. In this case, the land use types. These are shown in that legend to the right side of the screen, and the values in that legend show the AUC, or area under the curve, and higher numbers indicate a better predictive ability for the indicated class. As you can see, our model is very good with water and with the low density developed classes, and less so with the various forest classes. Here's a visual representation of what our model will output at the end of the workflow. On the top left, you see the ground truth label as it would exist in the NLCD data set. The top right is the predicted outcome for the image sample. The bottom left is the differences between the 2 models. And on the bottom right, you see the true color image of the sample area that was put through the model. Next, to talk a little bit about the pros and cons of our model is Megan Tan, who was our data steward and one of the code and programmers on the project.
Thank you. While we take pride in what we've accomplished and think our work will contribute to DNR's efforts towards salmon recovery, we understand that we're working with certain constraints, and there are still a number of enhancements that could be introduced that would bring with them possibilities of greater impact. In terms of the land classification model, one of the challenges we faced was blending data from 2 different sources with 2 different resolutions. Being able to acquire imagery at the same resolution would remove the need to scale and greatly improve the vector to raster conversion. Another challenge was that the ground truth data from NLCD was acquired at a specific time, whereas the training data was compiled from a year's worth of satellite images. And one of the strengths of the models is the ability to acquire satellite images regularly. Normal processes require very precise weather conditions, but this model takes a series of images that span space and time, selects the portions of usable data by filtering out things like clouds, and then pastes the images together into a cohesive unit. This does result in some error during the training, as the training labels are not a 100% accurate representation of the image being trained on. Another improvement to the training data would be having a better representation of all classes. The areas we worked with had limited development and were predominantly forest. We also looked to classify different types of forest, such as deciduous and evergreen and mixed forest. If the real priority for identification is purely binary, as in developed or undeveloped, we believe the accuracy of the model would be greatly improved while reducing computational intensity. For the growth model, we chose the best model out of those that we tested. While its predictive ability is high, we still believe that improvements can be made and encourage further testing of various models, such as those available through Urban Sim Library, which factor in real estate development and location. We're also working with a limited data set and believe exploration into additional features, such as those related to economy, population, and legal restrictions, would result in a more robust model. Also, special consideration should be given to feature selection in relation to class representation, as some of the classes in the dataset had small sample numbers. We think that further emphasis should be placed on undeveloped parcels. Here you see the distribution of undeveloped parcels by city. And on the next slide, you can see the 10 organizations purchasing undeveloped parcels. We think that by focusing on what types of buyers result in land conversion, and then looking at the features of the parcels that they're purchasing, we can further identify areas of risk for conversion and give DNR a short list of properties to protect, letting them consolidate their efforts. Matt?
Thank you, Megan. So in summary, some of the main recommended uses for our growth model and land use classification model are on screen before you. We believe that it will allow DNR to identify areas at high risk of development and to prioritize their response accordingly statewide. They'll enable DNR to form smart partnerships with local and regional partners and increase awareness of DNR programs as they relate to development and salmon habitat restoration and protection. We think that they'll allow DNR to inform salmon strategy responses and provide more context in the existing policy environment that they face. And last, it will provide an inexpensive way for DNR to validate the growth model and to gain insight into land use statewide. That concludes our presentation today. I would just like to thank all of you once again for attending and encourage you to reach out to us with any questions you may have or for additional information. You're also welcome and encouraged to connect with us on LinkedIn. Thank you.
Hi, welcome to our presentation on Facilities Dashboard for Data-Driven Decisions for the Tacoma Public Schools. I'm Joel Oringer. I'm a project manager and business analyst who's been working on this project with my peers for the past year. And I've been working as data steward and project manager and contributing to the majority of the deliverables.
Hi, my name is Mario Villa. I'm a program manager at AWS. In this project, I contributed to creating some of the dashboards you'll see today, as well as other analysis for our client.
Hi, I'm Swarnima Kumari. I'm a data analyst. I've been an active contributor on this project, mostly working around the predictive analytics and creating some visualizations in Power BI and Tableau.
Hi, my name is Cooper Cutler. I'm a financial aid program specialist.
I've been our client contact this year, as well as contributing on some of the data analysis and data stewardness. I'll be passing it back to Joel O'Ringer.
So, Tacoma Public Schools is one of the largest employers in Tacoma, with nearly 5,000 employees and over 30,000 students. They have to manage over 140 buildings and stadiums, fields, more than 5 million square feet of learning and administrative spaces, most of which are available for public use after the school hours. So as a data-driven district seeking innovation in their schools, they sought to leverage the power of technology to better understand their facility rental program and assess its impacts to better serve the students and the Tacoma community. The objective was to identify facility use impact and provide evidence for a business case outlining budgetary and full-time equivalent requirements needed to run and support this facility use program. Really, the goal was to maximize revenue and reduce costs to ensure that the program can be sustainable into the future and in harmony with the intended public benefits. So Tacoma Public School and UW-Tacoma's MSBA program partnered to find solutions and analytical insights to improve the visibility into their facility rental utilization, cost, and revenue. Our early discovery questions included things like how are the rental facilities and fields being used, who are the largest customers, which locations you receive the most use, and importantly, what the impact on overtime costs were to the school district. Over the course of a year, we had 4 phases. The first phase was business discovery, really understanding the business drivers at Tacoma Public Schools, do industry and company analysis, define the project scope. We use tools like Microsoft Project, pestle analysis, Porter's value chain, SWOT analysis, and the like to understand the business, and tools like SQL Server to understand the data a bit. That was driven down into more detail in phase 2 as we did data exploration and diagnostic and descriptive analytics. We were creating data flow diagrams, data dictionaries, a data management plan. We were using tools such as SQL Server, Visual Studio Enterprise, DevOps, and using tools like Excel and Tableau to visualize the data that we were encountering. Phase 3, we moved into predictive analytics, doing some machine learning and forecasting, predictive visualizations. We used R to do some neural networks and regressions against the data, Azure Management, Machine Learning Studio, and introduced some Agile and Kanban methodologies into the project. Phase 4 was about cognitive analytics and the deployment of the project. So we looked at artificial intelligence and looked at different ways to deliver the information. We introduced new tools like Python, Power Apps, and Microsoft Cognitive Services in this phase. So next we'll do a demo, starting with Mario on some of the visualizations that the team produced.
Thank you, Joel. Thank you, Joel. Yes, I will discuss two dashboards that we created in Power BI to try to answer some of the questions posed by Joel, which were given by the client. We created several of these dashboards, but today we're going to focus on 2 particular ones. The first one, we're looking at administrative time by the school district in managing the rental program. In this first chart, you can see is by the fiscal year, and it's by the facility, by the time that is taken to manage the administration of this facility. So for the first year, the first couple of years, we see about 2,500 hours of administrative time dedicated to approving, scheduling staff, and entering the schedules into the system. This other visualization here is the total staff time by hours, by location. So what we see here is that high schools or schools with large athletic facilities are requiring the most administrative time, and those are areas where the school district may want to focus a resource to help them with that workload. Below, we see the types of organizations that schedule events at the schools and the amount of administrative time that they use. The group one here, which is internal to the school, is by far the biggest user of administrative time. Billing is done by a separate entity within the school district, so we have a separate visualization for them. Again, they're using 600 plus hours per year on the billing for these facilities. This second dashboard focuses on the number of requests and the organizations that are making these requests. Again, in this first visualization here, you can see that the group one is by far, again, the biggest user. And this visualization below, it shows the same groups and also the amount that is invoiced to those groups. As you can see, group one, because it's internal, they're utilizing the most amount of administrative time, yet they don't contribute in the form of revenue to the school district. And that causes the school district to look for revenue elsewhere, like in group 2 or 3, which are actually paying customers. These visualizations here also shows you the number of events by quarter. Quarter 1 and quarter 3 tend to be the quarters with the most amount of usage, so it's probably a good idea for the district to allocate more resources during that time and manage accordingly. This dashboard, as the other one, we have the ability to filter by date, so we can move. If we're looking at a time period that we want to look at, we can do that. Or if we want to look at a particular group, say we want to look at 3 and 4, we can do that, as well as by location if we want to look at a particular school. So with that, I'm going to pass it to Nima, who will be doing a demonstration on predictive analytics in R.
Thank you, Mario. I'll be talking about the predictive modeling that we have done in this project. So first thing was to decide on the variables to use for modeling, and we decided to predict event hours against variables like location, event date, organization type, number of events, and invoice total. So we ran a simple linear regression model, which would give an idea of how our variables are associated with each other. And the thing to look here in the output console is the adjusted R-square value. Usually above 50% is considered good, and we got 61.08%, which suggests that our model is really reliable. And again, a lower p-value helps to support the evidence. Next, we moved to do a time series analysis in R to be able to forecast the facility usage in future. So this is a plot of event hour decomposed by monthly hours against time. Next, we did auto ARIMA model, and the thing to pay our attention is the AIC score, which is a suggestion of goodness of fit of the model. The lower the AIC score, the better it is. And we got a AIC score of 37.66, which suggests that the quality of our model is really good. Next, we went ahead and did a forecast plot. The one on the left side shows event hours against a time period. Auto ARIMA model does not factors in the seasonality component. So it did another plot, which is on the right side, which factors in the seasonality components and shows the curve. So what this plot suggests is unable to meet the demands in future. TPS need to maintain its current supply, which is the head count, to be able to function properly. Next, I will pass it on to Cooper to talk about more insightful findings we came across.
Thank you, Nima. I will be talking about Azure Machine Learning Studio. This is where we did some predictive analytics for the number of event hours that TPS is going to be incurring, as well as how much overtime they can be expecting from facility depending on the type of event. We used the neural network, which we found was the best model for us for this data. As you can see here, that when we go to visualize our results for our prediction on event hours, we can see that our coefficient of determination is a 0.85, which is really a fantastic coefficient of determination and show that this was going to be the best model for our predictions. We also did the same sort of a training experiment for the overtime as well, and found that the neural net was the best one for the overtime. And as you saw before, we did a predictive experiment, which gives us an output in Excel. Through Excel, we can actually take some of our information, such as the location of Wilson High School, the Wilson Athletics Department, and whether or not they're going to be using the pool or the athletics facility, and determine how many hours do we expect each of these events to be. So we can see here that we predicted 2.6 hours if they're going to be using the pool, and 2.2 hours if they're going to be using the athletics or gym. And so using this, TPS can determine what staffing needs they're going to need. And when we're looking at these staffing needs, how much overtime is going to be incurred. Again, using a date, time, as well as the type of overtime, what is the reason, location, and type of location, such as the pool, theater, internals. We can determine how much hours do we predict are going to be needed for each of these events, and really predict what staffing needs they're going to need in the future. Moving forward, I'm going to be talking about our cognitive services. We found that Tacoma has 19.6% of people that speak a language other than English, and that TPS has a website and forms that are all in English and may need some assistance to be able to provide more information to the neighboring cities and really the people that are going to be attending each of these schools. And so we suggested using the Microsoft Translator API, such as you can see here, to be able to convert this into a different language so that people can be able to understand and be able to fill out the forms more correctly. So as you can see here, you can have English, Russian, Chinese, or Spanish, in addition to many other languages. And you can even do text-to-speech or speech-to-text, whatever is going to make it easiest for you. So now that you've seen all of this, we can look in the key findings that we found. So from Mario and Nima's visualizations and through the predictive analytics, we can see from an administrative standpoint that the internal school activities utilize the most admin time at 47%. And the locations that are using the most administrative support are the high schools and athletic fields. For scheduling events, we can see that the majority of scheduled requests are for those internal groups, and that those numbers of requests and event hours remained high up until Q2 2020, when the COVID-19 impact occurred. Continuing with these key findings, we can see that based on the TPS facility history in Q1 and in Q1 prior to COVID-19, that TPS was on track to maintain their current usage as well as seeing an increase in the potential bookings. This means that if they wanted to see what was going to happen in the future before we had this pandemic, they could use our predictive analytics to be able to see what are those future hours based on organizations and what is the overtime usage, based on the reason and the location type as well. Some potential changes that we would like to see and have offered to them is the cognitive services, when they can implement a text translator for their public website and available forms so that they're more accessible to a larger part of the community. Thank you for attending, and we'd like to see you at our poster session from 1 to 2. Join us there and we can answer all of your questions. Thank you.
Greetings and welcome to the Analytics Innovation Club Showcase video. My name is Chris Dinsmore and I will be your narrator and host. This video will introduce our club partners at the Center for Business Analytics, go into some background about the MSBA program. We will hear from our program advisor, Luna Zhang. Then our club president, John Cannon, will join us for a few words. We will then get into the meat of our work from the past year. First, John Cannon will talk about our work with the Korean Women's Association. Then Michael Turek will have an update on the club's work with the Washington State Historical Society, followed by a fascinating presentation from Dr. Margot Bergman and Drew Gordon on measuring consumer confidence in the time of COVID-19. We are very fortunate to be partnered with the amazing folks at the UW-Tacoma Center for Business Analytics, headed by Haluk Demirkan, PhD, Milgard MSBA faculty, director of the Center for Business Analytics, and the founding faculty and director for Informs Student Club and our Analytics Innovation Club, as well as Michael Hessler, PhD, CBA Center Manager, Ellen Hermanson, Program Advisor, and Merv Kayan Surter, Technologist. We are here today thanks to the Masters of Science in Business Analytics program at the University of Washington, Tacoma. A 12-month work-compatible STEM-based program prepares students to work in the data-driven digital era. This interdisciplinary MSBA is designed for professionals and college students who want to sharpen their critical thinking, problem-solving, creativity, and data analytics decision-making, digital technology enablement, and project and process management skills. In addition to the support we receive from the Center for Business Analytics, we are honored to have Dr. Luna Zhang as our faculty advisor. Here is Dr. Zhang with a few words.
Hi, I am Dr. Luna Zhang, the faculty advisor of the AI Club. The AI Club is established under the Center for Business Analytics at the University of Washington, Tacoma in 2019. It is not only a registered student organization, RSO for short, but also the only registered student chapter in the Informed Society and the UW system. The mission of our AI Club is to encourage interest in the field of analytics innovation, including data analytics, digital innovation, machine learning, and artificial intelligence, and to provide a means of communication among people, including students and community partners, to provide a means of communication among people, including students and community partners who are interested in analytics innovation. From the establishment, the AI Club has been active in developing a pipeline of community engagement projects, such as the Korean Women's Association, KWA for short, Data Reporting Project, the Washington State History Museum Twin Festival Prediction Project, and the Washington State Economist Consumer Confidence and Social Media Analytics Project. Due to our outstanding work this year, the AI Club has been nominated for the RSO of the Year Award. I myself has been nominated for the RSO Advisor of the Year Award. And the president of the AI Club, John Cannon, has been nominated for the Outstanding Student Leader Award and UW Tacoma.
Thank you very much, Dr. Zhang. Next, we will hear from John Cannon, the president of the AI Club at the University of Washington, Tacoma. Without John's efforts, none of this would be possible. He has put in many long hours to set up the club, and as well as work on many of the different projects and be a constant sounding board for us. John?
Thank you, Dr. Zhang. One of the purposes of the Analytics Innovation Club is to offer student consulting services to the local community. This year, we have targeted nonprofits as partners in order to give our student members an opportunity to get hands-on experience with real business problems and digital transformations. Our students get practical experience as well as helping a nonprofit that may not have the resources to take on these types of projects.
In addition to Dr. Zhang and John, today we will hear from Michael Turek, Drew Gordon, Dr. Margot Bergman, and of course, I am Chris Dinsmore. Okay, let's get to the first big event. John Cannon will talk about the amazing work the club has done this year with the Korean Women's Association. Take it away, John.
The Korean Women's Association was the first project that the AI Club partnered with for student consulting projects. The Korean Women's Association is a social enterprise that began in the early 1970s to advocate for Korean culture. Today, the Korean Women's Association is a social enterprise with 1,500 employees that provides numerous cultural programs, housing, legal assistance, immigration services, and food drives. The Korean Women's Association's primary business is in-home care of seniors and convalescing patients. The majority of KWA clients are billed through Medicare via Washington State. This is traditionally a low-margin business. In 2019, KWA implemented a new enterprise system specific to in-home care. This enterprise system operates on a website and mobile platforms with cloud-hosted data and incorporates new technologies such as GPS, geotagging for electronic visit verification. That is a new requirement this year for Medicaid billing. With this implementation came many challenges with training and data entry. For example, the smooth operation of the mobile platform is dependent on caretakers having a reliable cellular signal in the vicinity of the client or access to the client's home telephone. The business problem that the Korean Women's Association faces is that the data is not reliable. By the time the data has been corrected and reported to senior management, the data is often 6 weeks out of date and of limited use to make meaningful business decisions from the data. A more serious problem is that the data inaccuracy could lead to scheduled shifts that are not authorized by Medicaid, which is an expense that comes out of the bottom line, or shifts not being scheduled, which could be billed to Medicare, resulting in a loss of revenue. Our team's goal is to provide the Korean Women's Association more timely business intelligence by streamlining data flow and developing real-time dashboards of important key performance indicators. On the next slide, as we consulted with the Korean Women's Association, we developed a scope of work that was broken down into 4 phases. The first phase is standardization of best practices. In January, we began working sessions with the KWA team to explore the data and reporting in their in-home care system and developed a data flow architecture that will provide accurate and up-to-date KPIs for management dashboards. At this time, we continue our working sessions with domain experts at KWA to develop best practices. Phase 1 will wrap up in mid-June, and we will be providing a best practices handbook for standardization of data entry, reporting, and other procedures. Phase 2 will begin this summer with the next MSBA cohort and consist of producing a real-time management dashboard. Phase 3 will consist of modeling for caretaker scheduling, travel, and other areas of business. Phase 4 will involve more advanced dashboards that support the business decision-making process.
Thanks, John. A big thanks goes out to the Korean Women's Association. They have been amazing partners, and we look forward to continuing our work with them in the coming year. Next up, we will hear from Michael Turek regarding the club's work with the Washington State Historical Society. Michael?
Hello, my name is Michael Turek, and I am project manager for the Washington State Historical Society project. Every year, the Washington State History Museum hosts its annual Model Train Festival beginning on or close to December 20th. The event draws the museum's highest number of visitors per year. Out of the approximate 80,000 attendees the museum draws annually, the Train Museum attracts anywhere from 500 to 1,000 visitors per day during a 10 to 14-day period of the festival. The attendance for the festival, however, varies widely year over year, and the Washington State Historical Society is curious as to know why. What is it that truly drives and impacts attendance to the festival? And furthermore, how can this information be utilized to maximize attendance each year? It is our group's task to uncover the data-driven answers. The initial data set that we received contains 100,000 rows of museum admission transactions ranging from January 2012 to March 2013, along with the complete exhibit list for this corresponding period. While we have this abundance of historical data for the museum attendance throughout the year, it was determined that our real variable of interest and what we are trying to understand is daily attendance levels for the Train Festival only. So we were able to take the provided data set and derive our own new data set of rows of daily information for the dates of the Train Festival. So with this, we are working with a finalized small data set of 86 rows with daily attendance as their dependent variable. The variables of interest include day of the week, 5 distinct ticket types that we have derived through grouping, daily revenue, the prior event type leading up to the Train Festival, weather on the day of the festival, and the weather 7 days prior. Our first step of the analysis begins with visualizing the data using Tableau. Following that, even with a small size data set, we still will be testing various forms of linear regression. In developing our model, high emphasis will be placed on permutation feature importance to understand which variables truly are impacting attendance. And lastly, through time series analysis, we'll be forecasting estimated attendance levels going forward. So I invite you to view our poster session to see our insights and discoveries today.
Thank you, Michael. A big thanks to the Washington State Historical Society. They have been amazing partners, and I know we are starting to get some good insight into their data. The final project came to us because of the recent COVID-19 business interruptions. Before we go any further, we would like to acknowledge the impact COVID-19 has had on many in our community. We are forever thankful to the brave folks who go to work every day in the front lines battling this virus. For many of us, the economic impact of the virus has been at the front of our thoughts. I know after the shock of the entire pasta aisle being sold out, I started to think about my macroeconomics classes and how economists used replacement products to measure the strength of the economy. Their theory being in good economic times, people buy the expensive brands, and in tough economic times, people tend to buy the cheaper brands. This is completely thrown off when purchase preference is based completely on what is left on the shelf. Here are Margot and Drew to discuss the work we have done so far.
Thanks, Chris. The catalyst for our work has been the arrival of COVID-19. The sporadic spread of the virus has caused many governments to enact reactionary local policies, thus breaking the higher level tools which are used to write policy. In our case, Washington's Advanced Planning Committee is requesting a replacement for the National Consumer Confidence Index. Our goal is to build a localized index to assist the phased economic reopening plan. In our hunt for alternative data sources and methods, we've turned to Twitter posts and Google searches, which have proved to be legitimate indicators in past economic crises. Dr. Bergman, would you explain a little bit more about these methods?
Looking at our two graphs here, what we have are the two different analyses that we're using. One is a Google trend analysis. This is the graph on the left. And this is a correlation between the keyword basket of automotive terms and the CCI, or the Consumer Confidence Index, from 2004 to the present. And what you see here is how well that particular term is related to the Consumer Confidence Index over time. Because what we're trying to do is get a sense of which actual terms work best for predicting consumer confidence. And then on the right, we have our Twitter analysis of a 1 month kind of grab of the current analysis of people's concerns about the coronavirus and their economic status during that, and what is concerning them about going back to work, unemployment, pay. And we're looking here to try to develop a sentiment analysis in order to build a snapshot of the consumer confidence locally, which is something that we can't get from the Michigan survey.
Thank you, Margot. A big thanks to Tyler Ray of the Washington State Patrol for being our contact as we have begun work on this project. Now I would like to take a few seconds to talk about the Analytics Club Advisory Board. As this year came to an end, it became clear the club projects would extend into the next cohort. This year's club wanted to ensure continuity as club members changed from year to year. For this purpose, John Cannon, Michael Turek, and myself have formed the advisory board. Our purpose will be to ensure projects are guided from year to year, provide a sounding board to the club, and lead efforts as we continue to build partnerships in our community. In fact, we are currently looking for a partner who is interested in sponsoring a scholarship for analytics students. If you or your organization is interested, please reach out to John, Michael, or me. And now some closing words from our club president, John Cannon.
Amazing work we have done this year, and we are so excited to see our work continue. As we move forward into the 2021 academic year, the AI Club and its advisory board continue to look for business partners for student consulting work, as well as partners to support an AI Club scholarship that we would like to implement in the near future. On behalf of the AI Club, a big thank you to the Milgard Center for Business Analytics, the Korean Women's Association, the Washington State History Museum, the Washington State Economists, and Informs for being our valued partners. Thank you to our student and faculty members who have made these projects come to fruition. And a special thanks to Dr. Luna Zhang, our faculty advisor who's guided our club throughout the academic year. We welcome the class of 2021 and look forward to what the AI Club will do next year and in all the years to come. Thank you.
Okay, John, can you go back, and you had some of your bandwidth issues there at the beginning. Can you start? Yeah, can you start at the beginning and just run through it?
Sure.
About half, yeah, just run through it one more time just to make sure we get it good. Just go when you're ready.
Amazing work we have done this year, and we are so excited to see our work continue. As we move forward into the 2020 academic year, the AI Club Advisory Board continue to look for business partners for student consulting work, as well as partners to support an AI Club scholarship that we would like to implement in the near future. On behalf of the AI Club, a big thank you to the Milgard Center for Business Analytics, the Korean Women's Association, the Washington State History Museum, the Washington State Economists, and Informs for being our valued partners. Thank you to our student and faculty members who have made these projects come to fruition. And a special thanks to Dr. Luna Zhang, our faculty advisor, who has guided our club throughout the academic year. We welcome the MSBA class of 2021 and look forward to what the AI Club will do next year and all the years to come. Thank you.
Hi everyone, my name is Dr. Marian Eberly. I am an associate professor of management here at the Milgard School of Business, and I teach in the management area. At the undergrad level, I teach classes like Intro to Management, International Management, as well as Team Dynamics. And in our Masters of Business Administration program, I teach a class, it's called Individual and Group Dynamics. I've been really excited over the past year to become involved in the MSBA program. And so where I come in is I work with students, in particular the applied project teams, to develop healthy and constructive team dynamics. And so there's a couple of workshops that I do, one at the beginning of the program where students are just meeting for the first time, where I provide some guidance on how to basically start strong as a team and how to build really consciously a positive team culture. And then in the middle of the program, I come in again and we kind of discuss together, how are things going so far? What are some things that teams might be able to do to further improve their team dynamics? It's been really fun. I love being a part of the MSBA program and seeing the growth of the students and helping the students along the way to be successful with their applied projects.
Hi, I'm Dr. Margot Bergman. I am an economist by training, but I also study public health and healthcare decision making. So I'm a bit of a polymath, kind of multidisciplinary. I touch everything. So that's kind of exciting. And I teach in the Milgard School in the Master's in Business Analytics, as well as in the MBA and the undergraduate program. Analytics, I teach a lot of the quantitative courses. I teach the applied regression course, and I teach the analytical decision-making course. So I really focus on how people make decisions and how they make decisions with data specifically. And so statistics, linear programming, pretty much any way that you make decisions with data, I'm your girl. So we actually go out there and solve problems for the businesses, so you get hands-on real-world experience. And that is an incredible opportunity for the students to both network with the businesses and to learn real-world problems. And so I faculty mentor with our students for that. It's part of my job, and that is a really unique opportunity for our students. And so you need to be willing to get in there, learn how to code, learn how to do the work, learn how to work with the businesses, really make yourself an entire total package that you can go out there and get the kind of jobs that our students have been getting. So jump in, feet first. And don't worry if you don't have a bit of background, we'll get you there.
I am Dr.
Dr. Luna Zhang. I am an assistant professor of business analytics at the Milgard School of Business. So I teach the social media analytics and predictive analytics. And my research interests include the economics of e-commerce, mobile commerce, online consumer behavior, and also the interface between information systems and operations management. Yeah. So the Master of Science in Business Analytics program in the Milgard School of Business is different because it allows students to become T-shaped analytical thinkers and adaptive innovators, and to collaborate with smart Martians effectively and efficiently, and have hands-on experience on real-world projects with firms like Microsoft, Costco, and Boeing.
I'm Joseph Phillips. I'm the supervisor of surgery scheduling and reporting for the region at CHI Franciscan. I've been with the company almost 9 years now. So when I started there, they were charting in paper, and now they're completely converted over to an electronic medical record system. And in fact, I helped, I think, what you could say, form the education affiliation agreement with UW Tacoma, as I was looking for master's programs for myself. And my specialty, well, I would say, was in analytics and databases and things like that. Came across the Masters of Science in Business Analytics program here in the Milgard School of Business. So I looked into enrolling and attended some of the informational sessions, and I have a couple little kids, so the timing wasn't right. But I found out when meeting with Haluk that they do annual projects for local companies. So I thought it would be a really good opportunity to submit a few proposals and see if there was anything they'd be interested in working on. And I was pleasantly surprised that they chose 2 of the 3 proposals that I submitted to work on in the first year, which was really fun and exciting, but also we had to have there's a lot of important protected healthcare information, and getting all the HIPAA and other concerns, signed and legally okay to share information so that we can do deep dive analysis projects with students was not a challenge, but definitely something we had to fix or accomplish first. So we worked and officially had an education affiliation agreement created. And once we had that, we were able to really work with this. We were able to make all the students official volunteers at CHI Franciscan. So that's kind of part of the program. So they get volunteer work for resume building, as well as the opportunity to work on projects that are real in healthcare that we're on the forefront of trying to figure out some of the challenges, whether it's throughput or how to improve quality and safety and things like that. Projects that we've had the students working on, opportunity analysis for consolidating surgical specialties to specific locations was one challenge, but essentially we have 9 different locations, and we do a little bit of everything everywhere. And the idea of this project was to have the students run some of the numbers to see what it would do to throughput and if we consolidated certain services to just certain locations. So we had the students running a lot of reports and diving deep into the data to do some scenario modeling to see if we were able to mix around the patients and the services to go anywhere we wanted, how much potential capacity would we create by streamlining certain things. And they came back with some very encouraging recommendations and results that showed how much potential there was if we were to go down that path. So that was a really neat project to see that I believe is very connected with what we're working on right now. CHI Franciscan has formed a partnership with GE Healthcare and GE to build a command center, a mission control, in a sense, to monitor the patients in all of our hospitals in a centralized way. And it relates a little bit to that project that the students were working on, looking at all the cases across and recommending if you could move certain services to certain places, that it would create more access for patients in the future. So some of the recommendations that came from that project really help support and drive a huge initiative that we're working on right now. The other one was strategy for growth and investment in our robotics program. We have a really big robotic surgical program at CHI Franciscan, so the students were able to take a look at the services that were being done with the robot and working directly with the robotic vendors as well to talk about areas where we could grow and do more services robotically, because studies have shown that there's some quality and safety benefits to using surgeons driving robots to operate on patients. That's pretty neat advanced technology. So I think the students were pretty interested in seeing the robots and talking to surgeons. We had some robotic surgeons as a part of the group that were telling the students how they work with the robots and what kind of, answering some of the general questions they had. And I think to most of the students, healthcare and how they can apply high-level analytics is a little bit of a mystery. Like, how do you apply all this analysis and all these skills and classes that they're learning to actual projects that are in healthcare? If you're not a doctor or nurse, what other jobs are there in healthcare? And I think this education affiliation agreement with UW Tacoma, or University of Washington Tacoma, and CHI Franciscan has really given us the opportunity to show how the work that they're doing can directly impact healthcare and the community, and thus the communities and people around, because it can help us improve getting patients in the door, access to care. It can help us do things that would improve quality and safety, and it can also help us plan for the future how many surgeons we're going to need to take care of our community and things like that. The projects this year that we have been working on, surgical volume forecasting, predictive analytics, looking at how many surgeons we have to serve the communities, and based on how many surgeons are coming and going from our system, if we have enough to meet the demands, I guess you would say, of the population, and as that changes and grows, and to help us take into consideration what factors we need to accurately predict how many surgeons we will need to meet the demands of the population in the community. So it's been really fun I'm one of the few people, it feels like, that has, well, there's not one of the few, there's several people in our organization that have an analytical background, but to have a whole team of students that I can throw a story problem to and have them really dive in and spend a year focusing on how to give us the best possible answers or recommendations, leveraging the classwork that they have, has been a real win-win for our company and for them, I think.